So let's talk now about key methods in Java Phaser. And as I mentioned before, there's a heck of a lot more of them. Remember when we looked at CyclicBarrier and there were basically two methods, await and maybe reset and a couple constructors? Well, you can see that there's a lot more methods in Phaser. And the reason why there's a lot more methods is it supports a broader range of use cases. In particular, it supports these dynamic use cases. Fortunately, many of these methods aren't used very much in practice. They exist, but you can do an awful lot of cool things with a phaser without ever having to use them. Let's take a look first at the constructors. So there's a couple of constructors, and they're going to be used to initialize the phase number. And you can see this constructor. Oh, and the constructor starts out with the initial phase number initialized to 0. So we start out in phase 0, and then we increment from there. This constructor specifies the number of parties that are needed to advance to the next phase. Now, what's interesting about this is just an initial value. You can override this, or you can add to it using other methods. The number of registered parties, which can be changed dynamically, by the way, dictates when a phaser can advance to the next phase. So only after that many parties have shown up will it advance, or can it advance to the next phase. As I say here, this constructor is somewhat optional because the parties can always register later using various methods. With the Java phaser, the number of parties need not match the number of threads. There's some other things that you can do to make that a bit more dynamic than it is with things like CyclicBarrier, where they have to match one-to-one. This constructor, the default constructor, doesn't specify any parties initially. They're going to have to be added through other means. And therefore, you'll have to register other parties in other ways. And we'll see there's a bunch of different ways to do that. There's ways to register a bunch of parties all in one fell swoop. There's ways to register parties one at a time as they come online, and so on and so forth. Here are 5 key methods that parties or threads can use to register, synchronize, and terminate a phaser. And we're going to talk through each of these. And they're a little bit confusing at first. So here are 2 methods that are used to add unarrived parties to the phaser. So one is called register, which, as we'll see, registers 1, and the other is called bulk register, which registers a bunch. Again, the number of registered phasers at any given point in time dictates when the phaser can advance to the next phase. So again, register registers 1, bulk register can register more than 1. Then there's also a bunch of methods to arrive and await advance. And this is a little confusing at first. The reason why there's multiple methods here is it gives flexibility with respect to arrival and waiting to advance. And we'll see that when we look at some of the case study stuff here shortly. So there's arrive, await advance, and then there's arrive and await advance, which combines these 2 things. So let's start by talking about arrive. Arrive arrives at a phaser, but does not block until other parties arrive. So we're not awaiting anything, we're just arriving. You can think of this as similar to the countdown method in CountDownLatch. When you call countdown, it doesn't block. It just says, I'm here, and it goes ahead and decrements the count by 1. Arrive returns the current phase number, or it'll return a negative value if the phaser has already terminated. So that's the way you know if you're arriving at a phaser who's already been shut down. Arrive is not used very commonly in practice. There's another method called await advance, and it blocks until the phase of the current phaser that await advance is called on advances from the given phase that's passed as a parameter. You can think of this as sort of like the await method in CountDownLatch, where you call await and you block until the latch reaches 0. Kind of along those lines. It's more flexible than that, but it's kind of the idea. It returns immediately if the current phase of the phaser doesn't match with the phase that's passed in as the parameter. And you'll see how that works when we get to the example as well. This method is also rarely used in practice, although I will show you a way to use it in just a moment. The most common way of using a phasor is to use arrive and await advance, which arrives at the phasor and blocks until all the other parties arrive. And this is essentially equivalent to calling await advance with the result of arrive. This method is very commonly used, and you can think of it as being quite like the await method on Java's CyclicBarrier. In fact, we'll take a look at an example here shortly that uses it in very much the same way. Then there's also another method called arrive and deregister, which arrives at the phasor and deregisters without waiting for others to arrive. And this is going to reduce the number of parties required to advance in future phases. And that may seem absolutely mystical and bizarre, but when you see the use case we'll look at, when we take a look at the case study, you'll see why it's useful. It's useful because it allows a bunch of threads to coordinate their starting, and then the orchestrator thread arrives and deregisters itself so all the other threads can run, and this guy then gets out of the way to do something else. In fact, that's what it says here. It's often used by the party that controls the initialization of a phasor, and I will show you that use case here shortly. Then there's also a method called OnAdvance, and this is a hook method that performs an action upon pending phase advance. And this method is invoked upon the arrival of the party that will advance the phasor. So remember, when the final party shows up and causes the count to reach the desired count, that means they can advance. Right before they advance, the OnAdvance hook method is called back. And while the OnAdvance method runs, all the other waiting parties are dormant or suspended. They are not running. They're not doing something else. This method is very similar to the barrier action on a Java CyclicBarrier, with one important difference in that it can be used to terminate any further processing of the phasor. And it does this based on what it returns. So if it returns a value that's true, that is used by the phasor implementation to shut the phasor down, to terminate it. If it returns false, the phasor will continue on. And by default, the OnAdvance hook method, which doesn't have to be overridden unless you choose to, will return true if there are no more registered parties, if all the other parties have gone away, if they've deregistered themselves. Then it'll cause the phasor to be done. And I'll show you how to use this hook method here shortly too. Okay, so that's an end of the overview of the key methods in a Java phasor. In my experience, having looked at this stuff and taught it for a long time, it's not really clear what the heck any of these things do without looking at some examples, which we'll do next. In contrast, the CountDownLatch methods, countdown and await, the CyclicBarrier methods, await, are very simple to understand. They're very intuitive. If you think about them and you know what they're doing, you can kind of ferret out what is happening. In contrast, these things are more complicated.